Hi everyone, and welcome to Override's demo video for Milestone 3. Override is an educational, top-down party game inspired by games such as Overcooked and Playtime. In Override, you play as a college student struggling to complete his homework and striving for better grades. Through this setting, we aim to appeal to our target audience, who are first-year SOC students looking for something fun to do during their break while also refreshing their computing knowledge. Here, we have designed a simple main menu where players can start the game, view the controls for Override, or quit out of the game if it is downloaded on their computer as an application. Now, let us take a look at the instructions page. Here, players can view the controls as well as a brief summary on how the game works before exiting back to the main menu. Now, the play button. When players click this button, they are brought to the stage select screen. Currently, there are two stages available, the classroom stage and the house stage. The classroom stage has a simple and more beginner-friendly layout, while the house stage has more walls that get in the way of the player, as well as greater distance between objects. In Override, players are given 2 minutes to complete as much homework as they can, with each correctly completed homework increasing the player's score. Players must interact with a variety of objects around each map in order to complete their assigned homework tasks. When the game begins, players are given their homework tasks on a taskbar, which is situated on the left of the screen. The taskbar lists the individual colored reports that players will need to complete in order to finish the homework task. To do this, players must grab a correspondingly colored book. Each colored book corresponds to a different type of question, with red books giving programming methodology questions, blue books giving data structure and algorithm questions, green books giving math questions, and brown books giving random questions. These books can also be placed on tables for storage or thrown into the trash bins around the map to be removed from the game. Now, in order to study, players must take a book, bring it over to the nearest available computer, and then interact with the computer while the book is on it. This brings up the quiz menu. When players successfully answer a quiz question, they will be able to convert this book into a report that they can then submit for their homework task. Now, let me try answering this correctly. It appears I have answered the question wrongly. In this case, the book remains on the computer and it does not become a report. However, when a question is answered correctly, then the book will be converted into a report by the corresponding printer. This report can also be placed on tables and can be put into files that can be taken from the file table. After placing a piece of paper into a file, it will then be represented by this icon on top of the file. These files can be submitted at the submission table for homework, which increases my score, as you can see at the top of the screen. If players find themselves hard-pressed for time, they can also press the escape button in order to pause the game. In this menu, they are able to resume the game, or head over to the options section, where they can adjust various things and set their own controls for the game. Now, after returning to the game, let us wait for the time to run out while interacting with objects around the map. As you can see, once time runs out, the game will end. Here is the game over screen. On this screen, players can see the amount of homework they submitted and also return to the main menu. Now, let us briefly talk about how the game was created. Override primarily uses scriptable objects to store information. If we take a look at the scriptable objects section, we actually utilize scriptable objects for all of the items that the player interacts with. This allows the items to store their own sprite, which lets us later retrieve this sprite for the taskbar system that tells the player what items they need to complete their homework. Apart from this, we utilize scriptable objects for the transformation for the items. So when the computer table has an item on it and it needs to know what paper to transform it into, we use scriptable objects to store that recipe. We can see this in the computer table prefab. If we go into the prefab and we take a look at the script, the computer table actually has an array of these recipes that it cycles through whenever the player interacts with the computer table with a book on it, so that it knows what to transform it into and tell the printer to print that item. Finally, we also utilize scriptable objects for one last thing, which is all the finalized homework. So as you can see here, each homework stores a list of scriptable objects that indicate what makes up the completed homework. Apart from this, we also stuck to several design principles when we were making the game. So first, if you take a look at Unity's editor, there's a lot of items in it, especially if we go to, especially like just look at one folder, like look how much homework there is. It's really hard to navigate if we don't organize everything carefully. So we made sure to make a bunch of folders. So our prefabs have their own folder, our scenes have their own folder, our scriptable objects have a folder each for them, our scripts have their own folder, our scripts are organized into UI scripts, general scripts, yeah. So we tried to make a folder for everything so it would be easier for us to navigate the system. Apart from this, we also heavily utilized our prefabs. So if we go into our game scene, all of these are actually just dragged and dropped from our prefab folder. So this reduced the need for us to like keep duplicating our items, and also allows us to make like major changes to an item across the board. So this really helped us when we were making this game. Finally, we also tried to separate responsibilities to make sure that each script was only handling one thing, in which we learned from 2030S in OOP. So if we take a look at one of our prefabs, for instance, let's look at the table. If we take a look at the table prefab, we actually separated the visuals. So when our player looks at the table will actually light up. So that is stored, that function is stored in this selected visual script, which handles that. Meanwhile, we have a separate script on the main table, which handles the functionality of the table, which is when the player picks up and puts down items on the table. So those are the design principles we used when designing this game. Thank you.